Hi there, my name's Alistair Delva. I'm a software engineer working on a product called Cloud Android. Today I want to share some details about awesome new features in the Cuttlefish reference device. And everything I'm talking about today is available for you to download in AOSP. So what is Cuttlefish? Last year I presented Cuttlefish for the first time, and that presentation is still available on YouTube if you want to take a look. For the benefit of those that haven't seen it, I'm going to explain what Cuttlefish is and how you might want to use it in AOSP. So what is Cuttlefish? Cuttlefish is a device port of Android optimized for virtualization. What that means is that we've taken all of the things in a physical device that you need to build a useful physical device. We've tried to provide analogs for those features in our virtual platform. Things like camera, touchscreen, display, GPU, they're all being virtualized. And we've tried to do that in a way that is optimized for performance and optimized for the available feature set, so that the feature set in the virtual device as closely as possible matches what's done in the physical world. And that means that we get pretty good performance, pretty good correctness, and alignment with physical devices. The project as well also provides tooling for local and cloud execution. So when you build locally, there's a tool that gets produced by the build called Launch CVD. And that tool will immediately start the virtual device on your machine, assuming you've gone through the setup procedure. But we also make it possible to, from that same build environment, to launch the virtual device on Google Cloud. If you have a Google Cloud account set up already, you can actually start the virtual device, either a local build that you've done or some pre-existing build from ci.android.com on Google Cloud, and it will download the build onto Google Cloud or upload it from your machine, and then it will start the same local launching procedure, Launch CVD, to start the virtual device. One of the goals of Cuttlefish and AOSP is to provide a scalable, reliable, and conformant device. Scalable meaning that we can take advantage of the compute power available on the machine that it's running on, albeit on a small workstation or development board, or a large server with many CPUs and a lot of RAM. And part of the way that we achieve that scalability is by allowing multiple instances of the same Android device to run on the same machine at the same time. So in the diagram, you can see on the right-hand side, we have the Linux host, which is the machine you're running Cuttlefish on. The VMM is the virtual machine manager. That's the virtual platform, essentially. It's providing the features of the Android virtual device. And then underneath that, we can have many of these Cuttlefish guests, which include a whole operating system kernel and Android user space. And the user space builds can be the same. They usually would be the same if you were running like multiple instances of Android for sharding CTS or something like that. Or they might be multiple different guest images if you were running, say, an Android 10 version of the phone against maybe an Android 13 version of a foldable device. You'd be able to run them both at the same time on different versions. So we take advantage of this scalability, reliability, and its conformance characteristics, its correctness and conformance characteristics in our scalable CI system. And Cuttlefish is deployed and has been deployed for a long time now to the Android AOSP continuous integration system. So when you upload a change to AOSP and maybe a Googler sees your change and starts what we call pre-submits on that change, that will most likely be run through the Cuttlefish virtual device to validate that your change is correct. So we trust the system enough, the virtual device enough, to use it in our own continuous integration system. So here's an example of actually grabbing the source, building it, and running it locally on your workstation. Now, the first step, and this was contained mostly in my slides from last year, but this is just a condensed recap for you. You can go to source.android.com/doc/setup/create/Cuttlefish, and it will actually outline all the steps to install the Cuttlefish dependencies and configure a system for running Cuttlefish for the first time. You do need to always follow those steps at least once on any machine that you're going to be running Cuttlefish on. Once you've run those steps, though, you can get a copy of AOSP. So the example here actually includes the cloning and building instructions for AOSP as well. Once you've cloned down the platform, which is that make the repo init and source command. You can then launch the special cuttlefish targets. In this case, I've launched AOSP CF-x8664 phone user debug. But if you want to do an ARM64 build instead of an x86-64 build, you can also do that. Last time I discussed this topic, ARM64 was more experimental last year. But now we consider it to be kind of production worthy. So you can also just use that AOSPCF ARM64 phone user debug if you want to build an ARM64 version of the Cuttlefish reference virtual device. It will run more slowly on an x86-64 machine because when you run that launch CVD command there at the end, it will be using a virtual, like an emulator to emulate ARM64. But you can also take that build that you've built on your machine and you can copy it to an ARM64 device, like a dev board or a server. And you can actually run the virtual device implementation on those platforms at full speed. It will run using the virtualization capability of ARM64. So both of these options are viable in AOSP. Or if you don't want to build and run Android locally on your machine, maybe you have a machine with lower specification, or you want to run a more complicated Android environment for some reason, or you just don't want to build it because it does take a long time to build. You can still use artifacts from AOSP to experiment with the virtual device. So in the case here, we're using the acloud command, which is part of the AOSP environment. When you clone down this code and you run launch a target, you'll get acloud in your path. Or you can download acloud from another location just to have the acloud pre-built. And then you can run the acloud create command to create a virtual device. This will use any pre-existing Google Cloud credentials that you may have on your machine. And it will create a project in AOSP. It will download the build that you specify from ci.android.com, and then it will run the virtual device and allow you to access it from your web browser. So the example I've given here, there's two possible ways of doing it. You can use the acloud create with no build ID, and it will just fetch the last known good build from ci.android.com. Or if you want to fetch a build from ci.android.com and run it locally, you can do that as well. So this isn't using acloud. This would be using launch CVD. You can go to ci.android.com. You can look at the builds that are available, click on the AOSP_CF targets, and then download two files. It's either the .img.zip file and the CVD host package file. You need both of those files. Download those and extract them, and you'll be able to run that launch CVD tool to actually run that pre-built Android virtual device. So one of the new things I want to talk about this year is the fact that we've really invested in exposing every form factor of Android that's available in AOSP through the Cuttlefish virtual device. So we have example implementations, not just of the phone target that I've mentioned already, but also of a foldable device. So I'll talk more about that in a moment. The Android automotive device, Android TV, and the Android Go targets as well. So these are all supported in AOSP. You just have to vary the name of that launch target when you launch. So you can use AOSP CF-x86-64 foldable, for example, and it will build a foldable device instead of a phone device for you from AOSP. And as more variants of Android are become better integrated with AOSP, we'll continue to expose those using Cuttlefish. So two of the main areas of expansion and new form factor support are the foldable experience and the automotive experience. The foldable experience in AOSP, as I mentioned, you can use this AOSP CF-x86-64 foldable user debug target to set up your launch environment to start your build process. And then one of the main differences you'll see when you access the user interface on Cuttlefish, which is based on WebRTC and can be accessed through your local host machine, :8443. The port is 8443 for the WebRTC interface, is that you'll see these new buttons, these blue buttons that you can see in this GIF on the left-hand side. And these are actually changing the different foldable configurations of the device. So you can, for example, you can put it into vertical or horizontal orientation. You can have the hinge fold vertically or horizontally. So, for example, like clamshell, laptop style, or you can do it like a more conventional foldable device, and it will actually show you the multiple displays for the foldable device. So, as you can see, and when that fold transition happened there in the GIF, the second display will show up, and you can interact with the device through that second panel. And so this is one of the main differences between the phone device and the foldable device, is giving you these buttons to perform these interactions. So this is just giving you an opportunity in AOSP to explore with kind of the latest and greatest UX features of Android. And also hopefully makes it easier for you to experiment with building your own foldable device. We've picked a target for the foldable device, which is, we believe, representative in terms of screen size and hinge location, but all of the meta files that are used to produce this configuration are in AOSP and are customizable. So if you want to go into those files and change the hinge location or the sensitivity of the hinge or the point at which the transition starts for your hinge, or the screen sizes of your different displays, that's all something you can change in AOSP, and it will be reflected immediately in the Cuttlefish virtual device when you use the foldable target. So definitely something to check out. The second big thing, which is focused really on the automotive experience, is Cuttlefish's multi-display capability. So when you run with the AOSP CFX8664 auto user debug target, the target will start up with a WebRTC interface that contains two pre-configured displays. So you'll have the driver heads-up display, which is the display you can see in this image on the right-hand side, and you'll also have the infotainment display, which is where the maps are being shown currently on the main panel. As you can see, I'm running Google Maps right here, and we simulate the GPS location capabilities, so we can actually set routes and test all of that mapping capability on the virtual device as well. Multi-display is not specific to automotive. It's the first platform that we've exposed it on because it's typical for an Android Auto embedded device to have multiple displays. But the multi-display feature can also be used with other Android configurations. We do expose that capability in AOSP. But by default, when you launch this automotive target and you run it, it will pre-configure it with two displays, the heads-up display and the infotainment display. And it will allow the user to interact with both of those displays. These are being delivered as two separate video streams through WebRTC to the web browser, and we're using sort of like iframing to handle these two displays in the main system. And you can see in the automotive model here that we don't have multiple sets of buttons because the interaction buttons for controlling things like the volume, the home button, etc., are global shortcuts for the device. They're not per display. So when we talk about the other major thing that we've done in AOSP for Cloud Android for Cuttlefish is it's adding the multi-virtual device capability. So this is something that's very important for exploring device-to-device interactions. And one of the ideas, one of the motivations for this feature was that we really want to make all of those device interactions in the Android ecosystem work together better. So the Android Better Together initiative is all about making sure that Android and other Google devices can interoperate with each other and you have a good experience as a user and transitioning from one device to another. And any cases where those devices are working together to perform a task, we want to make sure that those experiences are good and they're reliable. So one of the things that we've done is we've made the virtual device also support having these multiple virtual devices running side by side. And allowing these virtual devices allowing these use cases to be explored using the virtual device. So we can even look at device-to-device interactions which perhaps don't even exist yet, such as form factors which don't exist, or application use cases that don't exist yet. And we can explore those by building out virtual devices that use those different device models and have them connected together. So one of the ways of how we're doing that type of connection is we've really invested in adding the better Wi-Fi and Bluetooth simulation, so better network connectivity between the different devices. So in AOSP now, the previous Cuttlefish networking stack has been removed. This provided a single ViRT Wi-Fi access point, but it didn't allow any of the things like Wi-Fi encryption or Wi-Fi protocols to be specified. And it would only allow you access to the internet. It was like a fake Wi-Fi network. The new implementation creates another VM which runs the OpenWRT project, which is an open source Wi-Fi router project. That project is running in a separate VM. We call it the Access Point VM, and is connected together over the network with the other Android virtual devices. So the OpenWRT has now assumed responsibility for the Wi-Fi credentialing and other capabilities on Wi-Fi. And the virtual devices can be linked together using those Wi-Fi interactions. Root Canal, which have been mentioned in previous years, but that's our virtual Bluetooth implementation, and that's also been modified to support multiple virtual machines connecting to it at the same time. So devices can see and pair with each other. File sharing between VMs is now possible using Nearby Share over Wi-Fi and Bluetooth connections. And a stable implementation of this will be due in the first half of 2023, but the code is available now in AOSP, and the structure shown in this diagram is currently how it works in AOSP. So really, that's all I wanted to cover. This is, as I mentioned at the start, that we're a fully open source project. Everything we do is in AOSP and made available in AOSP. Setting your device up is documented on source.android.com at that URL. And of course, AOSP contributions are always welcome. So please take a look at Device Google Cuttlefish and the Android Google Source project. And if you do upload a change, somebody on our team will take a look, and hopefully your change can be merged into the project. So thank you.